TabR is the name of the paper that we want to talk about in this video. It is going to be focused on tabular learning, and it's one of the examples of leveraging retrieval augmentation in optimizing the performance of the model. This paper is published in July of 2023, late July I would say, and it's a pretty interesting paper. So the genre of the paper is applying deep learning on tabular data. And basically the idea is that they want to bring in the advancements in the domain of retrieval-based modeling into the tabular domain and see how we can do that. So in a nutshell, the idea of retrieval augmentation has to do with bringing in additional examples or context from, let's say, the rest of the training data or the rest of the database or a real-time database and things like that, and basically enrich the context by which you are leveraging your input to generate a representation. Therefore, it would help, let's say, foundation models remain up-to-date or predict things that are more accurate. Now, this paper is about a positive answer to the question as to whether or not retrieval augmentation could be useful for training tabular models. And they proposed a model called TabR and show that using retrieval-based system, you can basically get great results and outperform a lot of the state-of-the-art models. This is the overview of their architecture here. You could see that you have the input being fed to an encoder, and the same basically types of observations are also considered as candidates, let's say from other examples in the database, and those are being fed to a retrieval module, which then helps using those along with the labels that those have to enrich the representation of the input, which was X, shown here, and then it will be fed to a predictor to predict the label for the observation. The retrieval module can be thought of as a generalized version of attention. There have been works basically expanding the concept of attention to beyond a single example and a single observation and going over more number of observations, let's say more basically attending between different data points rather than just between the different attributes or representations of the attributes. You can see that in order to kind of get the weights of these candidates based on the similarity to the observation, some sort of a softmax based or generalized version of attention can be used. Following this direction and also performing certain modifications such as focusing on Euclidean distance instead of, let's say, cosine similarity and things like that for the attention module, and improving the basically required computational complexity which happens in the works that want the attention and things like that. This work performs really well, and you can see that going from a transformer-based baseline, then adding the context labels, basically leveraging the labels of the items that you're using in the context, updating the similarity module, new value module, and then with the technical tweaks that formulates the TabR, they have been able to achieve good accuracy.